Hi everyone, this is Ritu from XGeeks. As you know, I'm always super excited to be here, and today is not an exception. So thank you for being here, and thank you for joining us to another one of our live streams. If this is your first time watching us, we're super happy to see you here. You're very much welcome. So let's make it the first of many times. If you've been following our work and you follow us in our social media or in other channels, thank you so much for doing that, and please keep doing it. And if you're watching us in the recording, that's also great. And we truly believe that content should not only be available online during the streams themselves, but also throughout time. So make sure to leave comments, make sure to reshare the videos if you feel like they are interesting content. We hope you do. And we hope you're enjoying this time with us. And if you don't know us yet, let's talk about XGeeks very shortly. XGeeks is an engineering company focused on providing capacity to product companies. XGeeks represents the perfect balance, at least that's what we like to think so, between project and product. And our teams across Portugal work in building products while dealing with a broad stack. So if you want to know more about XGeeks, our team, open positions, our content, and more, you can make sure to follow us on Twitter, LinkedIn, Instagram, Medium. Of course, subscribe our YouTube channel, because we think that we do some cool stuff over here. So I think it would be very nice to be able to share that with you. But as you know, and as you can tell already, I could be here talking all the live stream or doing the entire live stream about XGeeks, but let's leave that to another time. So, but with no further ado, I want to bring you a very special guest for our stage, Mary. Mary will give us a talk about event streaming and processing with Apache Pulsar. But before that, just a reminder to make sure that you can use the chat to interact, to leave your questions, to leave your comments, and we'll have some time for that, for questions throughout the live stream and at the end as well. So with no further ado, let's bring our super special speaker to stage. Hello, Mary. Nice to see you here.
Hi, Rita. Hello, everyone. Well, thank you. Thank you.
Thank you for joining us. We're super lucky to have you here sharing this awesome content with you. Are you excited?
Yes, very much excited. I actually didn't tell you yet, Rita. I will be coming to Portugal too for the J Nation. So I almost forgot to tell you.
Here. Oh, yeah. Mary, we need to meet face to face. I'm excited for that.
Yeah.
I didn't know that, you guys. So
Yeah,
I'm excited.
that's right.
That's
Yeah.
so cool, Mary. Can't
Thank
wait
you.
to meet you in person. Awesome.
Yeah,
So
thank you.
I'm excited. So a lot of great content, not only here today in our stream, but also in J Nation. So if you want to not only meet some of our team over there, but also Mary, that's the perfect event to go to, right, Mary?
Yeah, that's right. Yeah.
Nice.
I'm excited.
Me too. I got even more excited now.
Thank you.
This update of yours. Nice.
Thank you.
Mary, should we go and start your
Sure.
awesome talk?
Sure.
Okay,
Sure.
perfect.
Thank you.
Mary,
Thanks.
the stage is yours. Thank you so much. And
Thank you,
yeah,
Rita.
let's go.
Great. Thanks. Yeah. Okay. All right. Awesome. So, welcome everyone for coming to my talk today. And again, thank you so much to XGeeks for having invited me, and also Ottavio, who actually was the one that made the connection here. So really, really appreciate this. And again, I'm looking forward to visiting Portugal, very soon, next month. So, and today my topic is on event streaming and processing with Apache Pulsar. So my name is Mary Grigleski. I'm a streaming developer advocate at the company called DataStax, and they are based in Santa Clara, California. But then people who are working there, all of us, we are all scattered everywhere. I think just like a lot of companies these days, we all work from remote locations. So we are one of those companies, very progressive, very much into emerging technologies, doing things, that will make your life as developers easier. So, and this is my Twitter handle too, if you want to, follow me too. But I'll have more information afterwards too about how you can get in touch with me. So first of all, a bit about myself. This is kind of long version, but who's Mary? I'm again at DataStax. We're a database as a service company, NoSQL, Cassandra, open source is all about open source supporting, and big data streaming in the cloud native platform. And I was with IBM previously with the Java and WebSphere team for about 3.5 years altogether. And I'm based in Chicago. I'm also a very active tech community builder too. So I'm the president of the Chicago Java Users Group. I also help out with a few other like IBM sponsored meetups too in Chicago area. So I like to invite you to join our CJUG, Chicago Jug meetups too. Everything is still like, online right now. And my background, I have over 25 years of development experience, primarily in Java. I first started off more doing Unix and C and Linux, all these things, and then slowly get into, Java when it came into being, kind of 1995, 96. I actually started working at around 2000 when I got involved with Java. So since then, I've always been working with Java one way or the other. I also kind of get into cloud, DevOps, and I like emerging technology. So that's the area I'm in. I've done design, development, some technical architecture, integration, deployment, testing. So I understand very well, if you're developers, how, the whole process works. So with that, let me also, this is a quick slide I thought I'd share. This is my DataStax developer slide deck. So you can see that I'm also a Java champion too. I recently nominated as Java champion in November of last year. And again, these are just different logos representing myself, and streaming, distributed systems, reactive systems, IoT, MQTT that I've worked with recently too. So those are kind of my most recent areas of interest that I've been advocating for. Okay, so let's kind of start now. So agenda for today, event processing, event streaming, all these things are becoming so, kind of the buzzword, so to speak, right, everywhere. But what is it, right? It's also been causing a lot of, I'd say a bit of a confusion, because I think the name streaming can mean many things too. And it's on different levels or depending on what you're talking about, right? Streaming. But the thing is, I'm talking about here today is more about event streaming, right? And event processing. Messaging is really distributed messaging. How do you deal with, streaming data, right? Data as streams. And they are, kind of like the newer ways of doing things. And not like it's completely brand new, as we all know. But as such too, I feel that events are really mimicking, right? Like much more closer, like mimicking what human life is all about. We are about asynchronous processing. I mean, just think of the fact that if we don't have event and asynchronous type of processing, then everything we have to do, right, as humans, we have to sit and wait, make the request and wait for it to come back. So that won't work. So, but as such, we all know computing, right? How it all started in the beginning was more about, having data. We're viewing the world much more kind of, I wouldn't call it simplistic, but a bit kind of like easier to manage in terms of we give it more structure, we give it certain model that's kind of not, kind of as natural as how human beings communicate, was how we all started. And of course, then over time, right, as we can see, like I said, events is not a new thing. I mean, in the military, for example, right, they are already doing a lot of, communication stuff. And for example, if you are into like Erlang, right, in the 70s and stuff, they were developed to Erlang. The actor model, for example, is for messaging. And that actually is trying to support, the asynchronous style of like, communication, especially, real-time telephone communications. But back then too, things were a bit more kind of raw format. So now these days, right, when we're in cloud native times, everything is all kind of a lot more advanced now, and hardware is able to kind of be very sophisticated. We do multi-core machines, multi-CPU, all of these things. So anyway, I kind of drifted it off from my agenda, but I just kind of get all excited, as you can tell. So anyway, but back to this, I realized, okay, agenda. So let's kind of first talk about computing events, right? Event streaming, event processing, complex event processing, event-driven and message-driven. So like I said, just kind of let's all get onto the same page first about events. And then the event processing semantics, right? We have Pulsar. We have also queuing, right? Streaming and queuing. And then the pull and push kind of like way of doing things, right? It's all different than our traditional way. And then basically to then move on to the question of why we want to do event streaming, right? Again, why now, all these things. So let me kind of get back into track. And then let me then bring you, right, to introducing you to a very interesting library. Is actually an open source library called Apache Pulsar. So, and also Pulsar too is dependent on Apache Zookeeper. to help with metadata kind of managing, and also Apache Bookkeeper for doing bookkeeping, the log messaging, the storage. And then towards the end too, I'll kind of talk a bit, right? Well, you may be wondering that there are many other messaging systems out there, right? We know Kafka is like really the big ones, and RabbitMQ, all of the traditional MOM system, message-oriented messaging systems like RabbitMQ, AMQP, all of these things. So, but the thing is, let's focus a bit too on seeing how Pulsar compare with Kafka. So that's kind of the agenda. Okay, first of all, the many facets of computing events. I already kind of started talking because then once I kind of talk about agenda, I'm like, okay, well, events, that's my area. I've always loved it. Okay, so let's kind of get back to kind of square one. What is an event, right? Generically speaking, not even bring in any computing thing, right? And let's kind of take a look. So I look into the dictionary, Merriam-Webster dictionary, and essentially too, I look at all the definition. First and foremost, something just happens is an occurrence. That's an event. So, and then as you kind of page down to, this caught my eyes, the number 4 in here. The fundamental entity of observed physical reality represented by a point designated by 3 coordinates of place. So X, if you do math, right? X, Y, Z coordinates. So, and not only that too, we add in events is add in the time element. So time in the space-time continuum postulated by the theory of relativity. So that's kind of event in a more scientific way of talking about it. And that's where we are going to be kind of venturing into, is that aspect of events, right? When we talk about events in here, it's really like dealing with things and occurrences that are happening can be represented on the timeline. And essentially it's a point, but also has the time element. Isn't it fascinating? I mean, to me, I feel like that's why you see it being events very often is represented, right, as streams of data, things that are happening, data, and it keeps changing, right? The state of data, all of these things. So as you can see, from a computing point of view, it gets quite interesting and also quite challenging. How do you deal with time changes, effect of the time, things that happen, and they all happen asynchronously. Now, one data point is easy to track, is changes, but we live in a very complex world. Think of IoT devices, think of any kind of streaming type of processing. It's all these data that we're collecting that are happening. We're not dealing only with one kind of line of data. We're dealing with millions or gazillions or petabytes of data, especially today, right? Machine learning operations, operationalizing, all these things. So I'm just kind of giving you an idea. This is what event processing is meant to be for. Event streaming, event, all of these things. So, all right. So with enough of that, then let's get a bit into it. Event streaming processing. So what is it, right? It's really the practice of taking action on a series of data points that originate from a system that continuously creates data. So that's kind of like a, kind of a formal way of kind of interpreting this. But the event really refers to each data point in the system. And the stream is basically refers to the ongoing delivery of those events, at these different data points that are happening. So a series of events can also be referred to as streaming data or data streams. So of course, too, if we kind of talk about data streaming too, we're talking also about very, kind of common these days is something like a service such as Netflix, right? Any kind of online video streaming, online music streaming. These are being possible because of the streaming technology behind it. And we call it streaming too, but the streaming in a sense is really a consumer expecting the result of such. But again, we come back to dealing with the computing side. How do you make things happen, right? For the end goal. Okay, now then move on a little bit too, right? Again, if it's one events is easy enough, but then we live in a complex world. So complex event processing. So we also have often heard of this too. So what it is a set of techniques for capturing and analyzing the streams of data as they arrive to identify opportunities or threats in real time. So as such, we also know too in today's world, there's so much, kind of like as such, right? We are being equipped now with all of this capability through streaming, through other kinds of forms of technology. But at the same time, too, one aspect of application that you can use streaming is very important would be to monitor cybersecurity, right? Monitoring threats. So that's actually a very good use cases of it. So essentially, that's a complex event processing because you're dealing with many things that could happen that can cause some problems that you need to be aware of, right? To be aware of. So that's kind of more of a complex event processing as such. And essentially, complex event processing will enable your systems and applications to respond to events, right? If there's some threat happening, we analyze, we kind of determine there's an intruder coming from a different, IP or some IP kind of like questionable. It's an alert, right? You can then send an alert, and alert may be another downstream system to respond to that event. And also too, as thing happens too, and that's the goal too of event processing in modern day time, you can actually do real-time analysis. No longer do we have to deal with like batch processing, for example, right? So that type of stuff. Okay, so let's kind of move on then to more of the messaging side of event-driven versus message-driven messaging, the messaging side of things, right? Now we're talking about the individual messages that are being emitted, right, or exchanged, right? So, okay, so this definition I took is actually from Lightband, the company that invented Akka too, but Scala, right? Dr. Martin Odersky, the Scala inventor, that team of people. So they actually brought it, the event-driven, reactive systems, reactive manifesto, reactive systems, all of these technology, the Lightband, they've been leading it. And I really like that definition. They are describing event-driven. And then what's the difference between that and message-driven messaging? Event-driven is essentially, we're talking about a sender emitting messages, right? And so the sender doesn't actually usually worry about who is going to get the messages. And it's up to the subscribing clients, right? The subscriber, if they're interested in it, they can subscribe to the messages. So that's more of an event-driven kind of meaning in this. So it involves things, for example, an approach, publish and subscribe, the PubSub, commonly known as PubSub kind of approach. And then again, very often PubSub 2 will make use of a broker because you need some sort of middle person or middle agent, right, to kind of manage all of these messages. That's kind of, you need to receive it and then distribute it to whoever is interested in the topic. So very often with a topic, we have, actually I should say, with a PubSub scenario, you have a broker and publishers will publish the messages to a topic. So the topic identified that messages that are kind of, you label it, so then the subscriber knows what to subscribe to. And I don't want all the messages, I only want certain ones, for example. So that's event-driven. And then for message-driven, that's interesting. It's more about then a queuing kind of aspect, if you can think of. It's more about your sender and receiver. They are known to each other. It's kind of, that the sender receiver are kind of like already paired together. It's about queuing, right? It's kind of a dedicated, in some sense, it's a dedicated, your sender, it always sends to that one particular receiver. It's message-driven. The address is known. So those kind of differences. Now, then earlier I talked about event approach, right? We've been talking about events. And what does it replace? I wouldn't call it all replacing, but as such too, if you're already a developer, right, in doing, a lot of like big corporations, for example, you're processing data not during the day. Because, for example, you have trading systems, right? A place where I've worked at, you have traders that are registering or subscribers, you have vendors, all of these. So your daytime, your processing, you don't want to overload your system of managing systems of record. They are very important. Maybe their subscriber making changes, a trader making changes to their telephone number, something like that. So you want to kind of collect all those changes and then process them at an off hour. So then you don't take away the computing processing power during the day when the processor needs to handle more critical trading activities. So in that case, then very often, my companies will do what is called like batch processing. You collect, all the changes is there. Then at night, you kind of essentially crunch through all of those changes and then put them in place and remove certain records and insert certain records, update certain records, that type of stuff is batch processing. So something that kind of happens at more like a predefined time, and also usually happens in bulk and all of these things. So as you can see too, it could also cause, I wouldn't say like big problems, but then if you're, processing something really big, like a trading, let's say a trading volume, you need to do a trading clearing, right? So you need to clear all your trades during the day. Very often you can have many, right? Like a couple thousand, 100,000s of records of people buying and selling all of these things. So you batch it all together doing maybe clearing at night. So what happened is that if you're, very often systems are distributed, so you can have, you can create some kind of network load kind of, or in other words, you're processing so much data, you need to be reading it maybe from a real-time system, then you're gonna like pipe it all the data, for batch processing, and it can create some sort of networking kind of load at night too for processing this. Now, if you think of, right, doing events too, everything is happening dynamically. As it happens, you update the thing. So you kind of really lighten up all the load on your networking too. So that's kind of event versus batch processing. And of course, the biggest kind of advantage of doing events is that everything can happen in real time versus batch processing. But again, batch still has its place. I don't kind of dispute it. Certain processing, you still want to do it in batch. So, and now then kind of move into event messaging, semantics, and some patterns. So again, I already actually brought this up. It's about streaming, right? Streaming is actually, we're kind of more talking about is a pub/sub. We kind of associate with pub/sub, right? Publish, subscribe. I already kind of quickly describe it, is that you have publisher. Publishing client sends the data to who? To the broker, right? The middle person, the agent. So think of the broker too. It's like a post office, right? I'm here, I'm producing things. I'm the producer. I need whoever consumes me, I don't care. But I go to the broker and deposit all my data, whatever it is. I send it, but I'll label it, okay, broker, I have all these messages. It goes to topics, this and that and all these things, right? Or sometimes too, I don't do it, kind of like in batch, but I do it like as it happens. Data comes in, I write it, I send it to the broker, kind of like that. So broker is the post office. And then it's up to the broker to help, right? And I organize all of your messages. If it arrives here, I know that, on the consumer or subscriber side, then they would be the ones interested in the data. They'll be receiving it. But I can subscribe to some topic before the messages arrive. So that's kind of makes it very, very efficient, right? This kind of model, right? So you only subscribe to data that you care about, essentially. And then you receive it as it happens. So it's really big. So as you can see, in a cloud native environment that we live in today, it's actually a very, very kind of a highly recommended type of doing things. When you're doing like messaging, you want it is very scalable. So if you have a lot of messages coming in, it's actually, you make your system a lot more scalable too. But of course too, and not to say it's completely kind of what you call it, like perfect, right? We don't live in a perfect world, but as such too, a lot of times too, for streaming systems too, you also have to deal with back pressure. Back pressure is if you have producing too much messages, you don't want to choke your broker. You don't want to choke things. And in kind of like a cloud native environment, you want to scale it. Maybe you want to spin up more brokers to help you. And then you have topics too that you can partition off in different brokers too, that type of stuff. So it gets very complicated, but I just want to bring this up. Pub/sub is really kind of like a very important event messaging type of technology. Now, then move on to message queuing, right? So queuing is basically a form of asynchronous service-to-service communication, and it's really is extensively used now in microservices and serverless architectures too. It's perfect. But again, messaging queuing too is more kind of more of a message-driven type of approach. So you sender and receiver, they kind of know each other already. So basically, too, messages are stored on the queue until they are processed and deleted. Now, each message is processed only once, right? And by a single consumer. So you kind of know each other, who's going to receive me. And then you can be bi-directional too. Sometimes, right, your consumer side can become the sender over to the original producer side, like that. And basically, too, again, the goal of such is to decouple the heavyweight processing and to buffer or batch work and to smooth like spiky workloads too. So it has its place too for doing queuing. So sometimes too, when you have to choose a semantics for doing your work, so it depends, right? Depends on your use case scenario, right? I'd say if you're doing IoT, you're collecting data, let's say from a temperature sensor, then you might want to do a pub/sub type of scenario. Every time, right, temperature changes, you want to publish it to your broker, for example. And then the interested kind of program, other clients receiving side can subscribe to that topic and and monitor all the changes in a temperature kind of changes. For example, if you are, working in agriculture, you might want to install IoT sensors, kind of doing that type of stuff. So that will be a more PubSub type of thing. Otherwise, then doing queuing too is also good in the sense that if you kind of have a dedicated sender or kind of like a known sender and receiver, then you might want to choose doing message queuing. But the nice thing about this is I wanted to introduce you later, very soon, is Apache Pulsar that supports both kind of semantics too in its messaging streaming platform. Now, about event streaming. Okay, so what's driving this change, right? I think I already kind of talked about it. So basically, too, real-time data is what we are trying to achieve, right? Real-time data, we want, the perfect, I mean, the most advantageous thing is if you have real-time data, is basically as customer, if you are on some systems, if you get everything as it happens, right, more dynamic kind of data, you don't need to wait around. It's always good, right? It's always, you can't dispute it. It increase your customer service kind of experience, increase their experience, so to speak. And also too, in that case, if you're a business owner, if you have more dynamic type of systems that can process things right, as it happens, it helps you in your business too, right? So that's the advantage. And then of course too, I mentioned also briefly too earlier on with AI and machine learning, smart models from time series, event streams, those are complicated. It's basically using a streaming platform. You can construct different data pipelines. Maybe there's a source and then going to another intermediate sink, right? From there, you transform some data, some processing, and then you go further downstream to another sink that will receive things. Now, an example could also be like using Elasticsearch, right? A lot of times too, that you need to process a lot of data, maybe changes and things like that. You want the change be able to get search, right, dynamically. So things like that, you can actually create a data pipeline, and basically eventually you deposit, right, all the changes you read from some kind of external systems coming in, you process, and then you want to send it to a sink, an Elasticsearch sink, so you can actually have data being able to be searched right away, things like that. So that will be an example, and I want to kind of quickly show you how you can do to using Pulsar in the Astra DB and the DataStax Cassandra database too. So that will be something that coming up. And also too, right, I mentioned too about PubSub. The great good thing about it is it scales very easily too. So depending on the demands, of large volumes of data, right, you can actually scale up and down much more easier than if you have the traditional way of processing, right? If you just use bland or kind of like a very bland, HTTP RESTful API, how do you scale, right? It's much harder if you think of that issue. So using a PubSub approach, for example, that a system that supports PubSub, you can scale a lot easier. Now, why event streaming? So I already kind of talked about it. So basically, watch for events with the system or application, subscribe to topics to see certain event types, and make decisions on data in real time, not after the event. And you're able to then ingest high frequency of messages with very low latency. So that's kind of sums up, why event streaming. Apache Pulsar. So now let me kind of quickly introduce you to that. And what is Pulsar, right? So as such, Apache is open source project. And initially, though, Pulsar was created by Yahoo. And Yahoo at the time, right, in more like mid 2010s, right, 2014, 15, they started I believe they were using another messaging platform such as Kafka, but they realized that there's some shortcoming because of the cloud native nature of the modern system. So Yahoo decided they wanted to create another project that's actually a step sort of like beyond, and doing more unified messaging and streaming, all that stuff. So they created Pulsar. And then in 2016, soon after that, they donated it to Apache Software Foundation in 2016. And then in 2018, Pulsar already became a top-level project because as such, too, a lot more companies and developers were realizing that we need a system such as Pulsar. And basically, too, Pulsar already was designed, with the cloud-native needs in mind, right? So cloud-native, quickly kind of summarizing, right? It's basically cloud, it's a system that can run and be deployed, and all of these kind of, all the kind of complexity already, it has to be very efficient to operate in a cloud clustering kind of systems. So that's what it is. Pulsar was initially designed with that in mind, a cloud-native, cluster-based, multi-tenant type of kind of goals in mind. So, and also too, the nice thing about is that there are also different kind of client APIs that you can use. Primarily is Java, but there's also C# too, and Python and Go, Ruby, and there are also community contributions such as even Scala or Ruby, things like that too. So it is definitely getting kind of increase in interest in using this particular platform too. Now, the thing that's quickly I wanted to point out is the Pulsar. Why is it kind of more kind of efficient? Is because it separates out the compute and the storage. Very often too, we tend to forget when we're doing computation, there are lots of log messages that needs to be stored that, for transactional kind of tracing kind of purposes, right? So, and that's one thing is Pulsar is really strong in because it separates out the compute. Pulsar worry about the compute side and it delegates the storage to another library, which I'll talk about in just a second. So, okay, so Pulsar too, again, my message delivery, it has guaranteed message delivery kind of built into, and it's basically, it's guaranteed. So it's, if you are familiar with messaging, message delivery, their quality of service. So we support QoS 0, which is fire and forget, QoS 1, delivered to at least once, or QoS 2, which is deliver it once, exactly once, kind of like that. So we have different levels of messaging kind of delivery too. And then there's also the serverless side of things too for Pulsar. You might wonder, right? Well, I'm kind of building data pipelines, but I want to do certain types of transformation on the data as it goes along, but very lightweight. We don't want to take away, all of these data flow and all that. So Pulsar actually has a serverless function framework. It's called Pulsar Functions. So you can actually use this kind of interface, the API, to also further enhance your messages as they are traveling through the data pipelines too. I won't have time today to kind of demonstrate it, but I'll tell you too how you can kind of contact me, and then I'll kind of show more about Pulsar, the function side. And there are also other things too, which isn't being mentioned of this. There also Pulsar has a schema and Pulsar I/O. So I/O is if you want to build different kinds of connectors. We have some pre-made connectors, but there are also stuffs that, such as you want to be able to deposit the data right in your pipeline to another sink. So if we don't have we aren't providing you with that connector, you can actually write your own using Pulsar I/O too. So that will be something that I can discuss again later. And again, too, these are summarizing. So basically, it's a tiered storage offloads too. So Pulsar also can manages things that are, most of the time too, these are not like developer kind of major concern. Usually when we write code, right, we immediately figure out, okay, I need to maybe, process some transaction of people making deposits to their banks. I want to be able to update it and all of these things. So we deal with the actual processing part of dealing with making a deposit and then updating the bank account, not worrying about, well, these data are sitting here. I need to, how do we deal with long-term, kind of storage, things like that. So then that's a nice thing. Pulsar actually has built-in, you can configure it. So then you let Pulsar, the framework itself, right, the platform framework, to handle that type of aspect of computing for you too. So that's kind of a quick summary. Again, what is Pulsar, right? So I just want to show you a couple of kind of statistics too. Basically, it's a unified distributed messaging and streaming platform. It's open source, as I already talked about, from Yahoo, and now is part of ASF, Apache Software Foundation. It's cloud native. It runs on Kubernetes. You can run on multiple clouds or hybrid cloud, all of these things. And there are also 4 reasons why Apache Pulsar is essential to the modern data stack, which I'll discuss in just a minute too. But as you can see on the right-hand side, these are like different metrics, right, of the graphs. And so, yes, you can see too, between the time when it got donated to Apache, has a steady growth too. And then the statistics on these graphs is a little bit older, but 2021, so almost a year ago, we can see that it's reached GitHub stars is like 8,000, more than 8,000. And right now it's actually 9,000 something. I checked already. So it is steadily growing. And the number of contributions to also have been growing, and more people. There are also different vendors supporting it too. So DataStax being one of them, and we're kind of major supporter of this project too. And then also too, as you can see, the number of active contributors too has actually surpassed Kafka as well. So Who else is using Pulsar, right? As you can see over here, you can immediately recognize the big names like Yahoo, Comcast, Overstock, Splunk, GM, and Verizon. And then there are others too that are, just as well known, but they are in other countries as well. So again, brief history of Apache Pulsar. I think I already talked about it, so I won't step through it again. We all know it came from Yahoo. Now it's part of open source as Apache Software Foundation top level project since October of 2018. And Pulsar is different. How so, you may ask, right? Again, if you look into it, producer, sending messages to topic that's managed by the broker. Consumer will read the messages from the topic managed by the broker. And then broker itself is a stateless process that handles incoming messages, message dispatching, communicates with the Pulsar configuration store, and stores messages in the Bookkeeper instances. So this is where I'm going to bring in too, like with the Bookkeeper aspect. This is an Apache software project too called Bookkeeper. As such, right? Bookkeeper, by the name, it does bookkeeping. And what does it keep booking? What was the bookkeeping all about? In other words, there's also the nickname as being called Bookie. So the bookkeeper, his job is essentially to manage all of the logging, right? Log messages as things are happening, messages sent and received, we're logging all of those things. So as you can see, in a very busy system, you have so much log messages. So Pulsar doesn't want to worry about it. It delegated essentially over to Bookkeeper. It uses Apache Bookkeeper. And it's, helps with the persistent message store. And of course, now I'm just talking about it high level, but it itself too is quite complicated too. It's its own project standing on its own, right? So Pulsar works with it. And then Pulsar also depends on Zookeeper. As I think most of you are probably familiar now, right? Zookeeper essentially helps with managing clusters, managing all of the metadata, coordinating the task, between your clusters and everything. So it's more like a high-level kind of manager, managing all of these traffic, managing, you need to have messaging going back and forth between different components. So it also Pulsar uses that to help, managing this aspect too. And as you can see on the right-hand side, this is just a diagram that kind of show you that right. So again, broker too, we can have multiple copies and instances of the broker running as well, but Zookeeper will be the one that's kind of as such, right, managing all the chaotic things that can be happening. You can have multiple brokers, but only one can actually be the selected one, right? As we all know, in a kind of a complicated cloud native clustering environment, there's a leader election, things like that. So Zookeeper has its own leader election that determines who is the broker, who is the primary one, especially if you're dealing with payment system, right? That would be absolutely important. You don't want, multiple brokers to get into play, into that because your broker could be helping to, process the payment. Only one, kind of processor should be handling the actual payment, things like that, right? So, okay, so now we get an understanding of the Pulsar component. Let's kind of move on a bit to understand a bit of the tiered architecture design that it has, right? So essentially, distributed architecture supports horizontal scaling, right? And so if you have more, requests coming in, you're spawning off more brokers to serve things too. And there's also, as you can see, there's some difficulty, this kind of model, not difficulty, challenges. Let's look at it like that, right? So scaling, right? Okay, you can say we can do horizontal scaling. There are more requests coming in. But what about, you need to rebalance, right? All of the topics partition. We already have, say, broker 1 is handling, instance 1 is doing that. You're spinning off 2 more, broker 2 and 3 instances, right? So you need to balance it off. You cannot, sometimes too, you cannot have multiple ones handling the same requests, especially when it deals with payment, right? You don't want to overcharge your customers, for example. So those are kind of like common kind of challenges. But the thing is, with the way Pulsar is being designed, it's actually its own internal rebalancing type of algorithms that kind of help with the scaling, and it's also very efficient too. And as you can see, when you have Bookkeeper handling all of the log messages, then Pulsar can then focus on kind of doing all the rebalance and without worrying about all the logging, because the bookie is doing it for us. So, okay, so that's a challenge number 1. And secondly, too, if you have tightly coupled persistence and message serving capabilities, it can have high costs on historical data too. So again, with the tiered architecture kind of design, it kind of eliminates or kind of lessen all of these problems, right? It's not tightly coupled like that. Okay, and then so third one, trade-offs, right? To support partition topics came at the expense of messaging semantics needed for use cases such as queuing, things like that. So again, it's kind of basically we're saying that it helps you to cut costs. There's it supports partition topics, right? And all of these things. So all of these, well, as such, too, the tiered architecture of Pulsar is well designed, so then you don't actually have to worry so much about that aspect. And let's kind of move on just a little more. So what's the big deal, you might ask, right? So basically, it's fast, it's low impact, horizontal scaling. It reduces costs, think of it like that. You can think of having more components to handle different aspects of, worrying about rebalancing, kind of, more instances of the broker topics being partitioned in different, segment and things like that. So the Bookkeeper too will segment off all of the bookkeeping, the log messages and everything. It handles it. So Pulsar doesn't have to worry all of the details as such. So, okay. So as you can see too, broker is stateless and it's got built-in load balancing, instantaneous scaling, and zero impact disaster recovery too. So, and okay, and then let's kind of just kind of take a 30 seconds look into Bookie, right? The Bookkeeper. So what is it, right? So it's a scalable wall-based. So it's a specification base for doing writes, archiving, write kind of protocol. I forgot exactly that, but it's a writing write archive, a logging specification based, fault tolerance, low latency storage service. So it's according to spec and handles that scalability. And also very tunable too. You can tune it too for message replication, right? So all of these things, if you are into bookkeeping technology, right, ensemble size, write quorum, ACK quorum, all of these things, you can kind of configure it to do it for you. You can tune it too. And then basically too, they have journaling. Electronic journaling is fast write guarantee. And also too, for segment-centric data persistence is kind of through its e-ledgers too. So it has such kind of technology. So if you're interested, you can check into all of the Bookkeeper capability. Now, again, going back to Apache Pulsar, it solves the problems of bolt-on. So from an architectural point of view, right, this actually is really the next generation of enterprise messaging. It is a unified solution for PubSub, for doing queuing, for doing streaming, and for message mediation enrichment too. So out of the box capabilities, because of it being designed for cloud native, so you can do cloud on-prem and hybrid. You don't actually even need to change your on-prem kind of architecture. You have Kafka running, you have JMS, you have RabbitMQ, for example, on-premise. You basically can kind of put Pulsar on top and kind of work with the existing infrastructure too. And that's actually a very kind of a strength of Pulsar too. And the nice thing I wanted to bring up to its features is geo-replication. Now, these, of course, deal with kind of bigger companies, kind of kind of system too. You can have different have things kind of put onto different geography, and there are different ways of you need to configure, right? For example, in Europe, there's GDPR, this particular privacy data act, right? So you need to kind of configure it so that maybe certain data you don't want to kind of violate any kind of kind of exposing a kind of privacy data thing. You can configure it. We provide that kind of capability, but in America, probably less kind of concerned, then you don't need to configure such things. So there's that geo-replication aspect, multi-region support, data lake integration, and much more too. So it is still kind of like a growing type of functionality that we'll see a lot more importance and kind of kind of in the computing world, it will become more and more important because of its capability. So it unifies platforms, it unifies all of the messaging, all of the events in the enterprise. That's the potential of this library. And as a unified platform, as you can see, right? You can, this is kind of we drawn out in here. Pulsar, think of it as like a central kind of hub. You can kind of plug it in with the older system like Kafka or JMS or MQ, and basically it helps you to connect to different systems through its PubSub kind of capability. So this is kind of a picture, especially on the right hand side. Just wanted to show to you. And how is Pulsar different, right? So I'll go a little bit faster. I realize I'm kind of almost time now. I told Rita I would be 45 minutes, but give me 2 more minutes. Let me step through these quickly. This one, I think I already kind of show you this picture. Again, it's a tiered architecture, separates compute from storage and all of these things, so I won't repeat it. And it's really rich to ecosystem of connectors and clients too. As I mentioned to you, you can write different connectors too for like your syncs, for example, or data pipeline as it travels through the flow, right? You can write different syncs to receive data too. And the features, right? Again, I wanted to kind of quickly say is rapid patching, zero downtime, multi-tenancy, identity and access management, end-to-end encryption. So everything is TLS encrypted too. Okay, so just key differentiator, separation between compute and storage, which I already talked about. We're letting Bookkeeper to help with managing all of the log messages, the storage management aspect too. Secondly, is the native geo-replication. So this actually is a very good feature too, especially in large corporation. I think you can find this to be very useful. And there are different types of message replication mode and patterns, right? Synchronous versus asynchronous, active or active passive, selective message replication. So all of these things too is already built in. So as developers, you don't need to worry about that aspect of, let's say, doing large scale kind of replication across cluster kind of thing. Multi-tenancy, again, right, with this too, is already been designed. You can offer tenants. Think of kind of like an apartment building, right? You have managing all of these data, but you can separate them out into different tenants. And let me kind of quickly show you too, because I'm talking too much about kind of the theory aspect, but I'll show you too through Astra DB how you can kind of define, a tenant for your streaming. So flexible message processing model. So as I kind of described, I wanted to kind of quickly point out to you, there are 4 modes of message processing, right, for the PubSub side of things. So basically, there's an exclusive. If you look on the right-hand side, exclusive is much like queuing. You already know the subscription, it goes to a dedicated, kind of consumer. And then what if there are problems, right? Then you can choose the failover. You basically have 2 consumers, one act as the one to fail over in case the first consumer doesn't work or whatever. So, and then there's also shared subscription too. Shared subscription is a very important concept in the cloud native type of scenario, because you can have the same subscription being shared among different consumers that belong to the same kind of clustered kind of environment. Now, there's also a key share. So for key share is basically help you to keep the messages in order as well. So that's what the kind of aspect of it too. So these are like different 4 modes. So why Pulsar, right? Then after you reading all of these, I know I only go through like top level kind of thing, but we have RabbitMQ, we have other kinds of Kafka, for example. So basically, we wanted to say if you need both queues like RabbitMQ and stream processing like Kafka, you might want to choose Pulsar because we support both in the same platform, the same runtime, and you get easy geo-replication, multi-tenancy, and then if you want to persist all of your messages for a long time and you don't want to offload them to another storage, Pulsar has already had that built in. Performance, is also very good too. And then you run on-prem, right? And you want to kind of just add Pulsar in to kind of bring your system to the next level without you have to deal with the legacy system. So you can consider Pulsar too. DataStax, right? The company I work for, we have flavors of Pulsar too. So basically, DataStax, of course, we're saying, we bring Pulsar to further too. So we have what you call like the Astra streaming. It's basically a managed Pulsar platform inside our Astra DB, the managed Cassandra database platform too. So I'll quickly show you shortly Astra streaming. And then there's also Luna streaming. So Luna, think of it more like it's really the open source Pulsar that you can use, but you can purchase our enterprise support if you want, or you can just use Luna streaming essentially too, and basically run it on your own, and you can kind of talk to us and we can help you too. And then if you want to go all open source, you can always rely, kind of depend on the community to help too. And we also get involved with the community as well. So DataStax streaming offers, as you can see, Astra streaming, right, and Luna streaming. Again, Astra is the fully hosted SaaS platform, open source. And right now, wanted to say we are coming soon. We are seeking early access participants. So if you're interested, please contact me. I'll connect you with the right people. You kind of help, and you can kind of we're putting together some sort of champions program to recognize people that will be helping. So how is Pulsar different from other messaging platforms, right? So I just wanted to say, right, to be aware of, with Kafka. So Kafka can be tricky with the scaling because it doesn't have that separation of concern between the compute and the log messages. Kafka does everything by itself. So if you want to scale, it's just harder, right? You have to do a lot more planning ahead of time. If you want to scale, then you have to write algorithms to deal with the repartitioning, the rebalancing kind of part of things. So that's one aspect. And of course, Kafka doesn't have, originally wasn't developed so much, based on the cloud native needs. So then it doesn't have, for example, the geo-replication, the multi-tenancy, all of these things too. So that's essentially what it is. And so I just want to kind of point that out. And over here, as you can see, right, this is picture kind of describing it, right? It's basically Kafka has to manage both its log storages and its compute. So you can see too, it's just a lot more work, from a developer point of view. You don't want to have to deal with that kind of rebalancing as much. But whereas if you go to Pulsar, because of our tiered architecture, it actually handles that aspect for you quite well. Okay, so this is, again, another kind of slides that talk about compute and storage separation and the segment-oriented log management via the bookkeeper. And just a very quick demo. I won't kind of take a lot of your time. Let me kind of go over here, and I will have to stop sharing of that. But let me then share the other one quickly. Share. And Chrome tab, this will be quick, Rita. Okay, so this one is the Astra DB that I was talking to you about. So it's multi-cloud database as a service built on Apache Cassandra. That's what DataStax is. So I invite all of you to join it. If you go to astra.datastax.com. Now I have it on my slides, and I also have another slide for you if you want to kind of subscribe to us. If you don't subscribe, use your credit card, you can automatically get a $25 credit to use our Astra DB, and it's very sufficient for small research workload too. So now I already signed in. So if you haven't, you can kind of sign up quickly. Do not even worry about using a credit card if you don't want to. So I've already done it. So oops, let me kind of do it. Sometimes do it one more time. Okay, so as you log in, as you can see, you can create your database, right? That's the Cassandra database. And basically to the streaming, Astra streaming, right? You can actually create the stream too. And it's as simple as you can create your tenant. I talk about the tenant. This is Pulsar underneath the hood, right? So you can actually give a tenant name, of, let's say, today's, what is this, XGeeks. You can do that. And then you can pick any provider too. Isn't it nice? We have GCP, we have Amazon, AWS, and Azure. You can do that. And you can pick a region in here, right? So let's say that. And then that's it, right? You can do a pay as you go. Although, what is it going? I have to start with lowercase, so sorry. So let's say I want to call it XGeeks. Okay, and then over here, then you can then basically create tenant. And as you can see over here, it tells you how much it costs. Now, in my case, I've already created, the streaming. So, and of course, to make it useful, you do want to have streaming, in this case, work with our Astra database too. Now, I do not have time today to kind of go into detail as to how you can kind of, leverage on the our Pulsar streaming and then work inside the Astra DB. But let me kind of go back to my slides now. I have to stop sharing that. But again, I just don't, I'm running out of time, don't want to take time from you. So I'm going to stop sharing this, but you can all welcome to do this. And let me go back to my slides quickly, and then I should be done too in a second. Chrome tab, I'll go back to my streaming. Sorry, I should have not talked for so long. Okay, so where to go from here, right? And let's keep in touch. So these are like all the links, right? Pulsar, Bookkeeper, Apache Zookeeper, Apache Project. And then Astra DB I was just showing you is astra.datastax.com, and you can kind of play around with things. Cassandra NoSQL, very, very robust database. And then there's also Astra streaming here. Luna streaming, and then there's also a feature called CDC, Change Data Capture, which I have another talk for it too, and I can be happy to share with you if you're interested. And this one is an interesting slide I talked to you about. If you would like to get an additional $200 in credit, you do have to provide your credit card and enter the code open source 200 to get this, $300 a year, credit that you can use, right, for using Astra DB for free. So if you want to do that, I will share the slides with Rita, and Rita can then share it with you too. And also, I have a Twitch stream too on every week, Wednesday at about 2 p.m. U.S. Central Time. So I think then that would be 7 p.m. or 8 p.m. 7 or 8, right? Okay. So in your time zone. So in the evening. So if you want to follow me, I will be talking more. I like to talk more to not just streaming, but other things to Java, for example. And join us at the Pulsar neighborhood too. There's a meetup group that we're starting. Also, Apache Pulsar neighborhood wiki kind of website, or actually a GitHub page. So with that, I want to thank you all for having sat through my presentation. And I know I go over time, so sorry about that, Rita, if I'm taking too long. But I like to invite you to also follow me on Twitter, connect with me on LinkedIn, or I also have a Discord channel. If you want to continue the conversation, I'll be very happy to. And then I'm coming to JNation in just a couple of weeks. So with that, thank you, thank you, thank you.
Thank you so much, Mary. It was worth the extra minutes. Don't worry. It was 100% worth the extra minutes. So we're so lucky to have your content in our channel. It was a great talk. And I'm not a technical person, and I think I understood most of the things that you shared. So thank you so much for going so thoughtfully throughout all the content. Very nice. We also had several comments in the chat saying that the presentation was amazing, and congrats on that. So Mary, thank you so much for that. We don't have questions, but we have great comments, and I think that's also a good sign.
Yeah, that's good. Thank you everybody for taking your time out and watch the presentation. As such, right, I'd like to invite you to join me on my Twitch and Discord, and I will be sharing with you a lot of things are open source. So I think really wanting to invite you to continue the conversation. It's an exciting area. So, and thank you so much to XGeeks. Thank you so much, Rita, and really appreciate the opportunity. And I hope to see you in JNation.
Yeah, we'll see each other in a couple of weeks.
Yeah.
And, the invites extends not only to everyone watching us right now, but also people who are watching us afterwards. It would be lovely to meet you at JNation, which will be in Coimbra in June 7th. So I think it will be quite a great space for that. And Mary, thank you so much once again. And it was super nice to meet you and to have you here in the channel. And I think it's a good timing for us to wrap up this live stream. Thank you to everyone that watched us today, to everyone that interacted in the comments. Thank you to everyone that will watch us afterwards as well. That's also an important part. And make sure to follow Mary in all her social links and groups and so on. We'll sure do. I'll share them with the team so that they also join if they're interested. And Mary, one last thank you to you. It was awesome to have you here. And have a good rest of your week, everyone. Bye.
Thank you. And you too. Bye-bye. Bye-bye, everyone. Bye. Bye.